here are the quiz answers on capacitors. Alright, here we go. The first question talks about a cylindrical capacitor made of two concentric cylinders. The radius of the inner cylinder is given, and so is the radius of the outer one. Length of the capacitor is there, and you're asked to find the potential energy. Now remember that potential energy is not potential. Okay, potential energy is the product of charge and potential difference. So first you have to find the capacitance using this formula, 2 pi epsilon naught times the length by natural log Ra by Rb. Okay, that's Rb, where Ra is the radius of the outer cylinder and Rb is the radius of the inner cylinder. When you plug in those numbers, you get, see, actually I have not changed the millimeters into meter because there's no need. It's just a ratio. So you get 1.2 times 10 to the minus 8 farads, and then you find the potential energy, which is, for a capacitor, potential energy is 1/2 CV squared. So 1/2 times the capacitance times the square of the voltage, and that gives you 9.6 times 10 to the minus 8 joules. Question number 2, the capacitance per unit length of a coaxial cable, it's again made of two concentric cylinders, is 50 picofarads per meter. Now this time it's the capacitance per length, so it's C over L now. So that is 2 pi epsilon naught natural log Ra by Rb. As before, we got to find the radius of the outer cylinder, make that the subject, and obviously you got to calculate really carefully here, because first you get the natural logarithm of the ratio, and once you get that, you take exponential 1.112 and you get the answer as 3 millimeters. That's the radius of the outer cylinder. And then question 3, you have a parallel plate capacitor, voltage 6 volt, sigma, which is the surface charge density, is given. Got to find the separation of the plates. And here, intensity of the electric field is sigma by epsilon naught, or it's also given by voltage divided by the distance. So rearrange that to make the distance, which is the separation of the plates, the subject. Plug in the numbers and you have the answer. Remember that nanocoulombs stands for 7 times 10 to the negative 9. So nano is 10 to the minus 9 there. Okay, so that's the answer. And question number 4, a parallel plate capacitor with plate separation, so that's D, and the plate area is given. What's the capacitance with a dielectric of constant 2.4? Straight, just plug it into the equation and you have the answer. (32 times 10 to the negative 12 farad). And then you go to number 5. Again, it's a parallel plate capacitor, plates area given, distance given. What is the capacitance? This time the dielectric constant is 1 because it's air or free space. If nothing is mentioned, you take K as 1. Straightforward question. And you have the answer as 2.4 times 10 to the negative 9 farad. And number 6, you have this combination. You need to find the equivalent capacitance or the total capacitance. Now, of course, you see that these two are in series with each other. And so, the total of these two is the product divided by the sum. which is 6 times 3 by 6 plus 3. And do the same with the other one, because those two are also in series with each other. Product divided by sum. And then those two combinations are in parallel. Therefore, you just add them up to get the total capacitance. And you get 3.33 microfarads. That's the answer. Brings us to number 7. A charge of 2 microcoulomb flows into the plates of a capacitor when it's connected to a 12-volt battery. Okay, how much work was done? You have the charge that's flowing in and you have the voltage. Now for that small amount of charge, you assume that the voltage is constant. So the work done is the product of the voltage and the extra charge, dq, that comes in. It is the product. So take the product of the two and you get 24 microjoules. Number 8. It's again to do with a cylindrical capacitor, and we've done this before. So that's the formula. Plug in the numbers. Again, when you take the ratio here, just leave it in millimeters because it's a ratio. And you get the answer as 30 times 10 to the negative 12 farad. Brings us to the 9th one. Here you have a parallel plate capacitor. Capacitance is given, charged with 20-volt power supply. Then the power supply is removed, and a dielectric of dielectric constant 4 is used to fill the space. Now understand that when you use the dielectric, the capacitance goes up, but the voltage drops. Okay, so you could simply have done this straightforward by dividing 20 with 4 and you will get the answer. That would be the voltage. Or you could go the longer route by calculating the charge first. And then you know that when you disconnect the voltage, the charge is not going to change. Now the capacitance has become 4 times what it was before. And so you find the new voltage with the original charge, which I think is 0.2 coulombs. I've changed it now. 0.2 divided by 40 times 10 to the negative 3, 5 volts. Again, you could have done this directly. And that brings us to number 10. Number 10 is talking about 2 capacitors connected in series across an 8-volt DC source. What's the charge on the 2 microfarad capacitor? You got to remember that the charges on both of them will be equal because they are connected in series. Therefore, you find the total capacitance first. And that is product by sum. And that gives you 2 times 4 by 2 plus 4, which is 8 by 6, 1.33 microfarad. Then find the charge by multiplying this capacitance with the voltage, which is 8. So when you multiply, you get 10.7 times 10 to the minus 6 coulombs, which is 10.7. So 10.7 microcoulomb. 11th one. Wow, it doesn't need any explanation. Capacitance given, voltage given, find the charge. Now that's like a joke. Just take the product of the two. 240. That should have been, it's 40 times 6. Well, that's a mistake which has been corrected. It's 240 microcoulombs. And the last one, a parallel plate capacitor has voltage 2 between its plates, sigma given. What's the separation of the plates? Now this question was done before, so it's the same thing. Make distance the subject and substitute and you get the answer. Okay, I wanted to do this under 10 minutes. It's 2.125 times 10 to the negative 3 meter, okay, which is 2.125 millimeter. And thank you and good luck.